The theory of interrupt, I will not narrate too much. So I just say some basic concept of interrupt, and then we will do some experiment, do some demonstration on how to programming and design the interrupt based on hardware. Interrupt service is different with those function. So there are two kinds of interrupt. One is the hardware interrupt, and other is software interrupt. Interrupt is very similar with the elevator. In front of elevator, if you push a button, then the elevator will know in which level there are some people will require to enter the door. So interrupt is arranged by event, not by programming logic. So it's by event. For example, if there are some trigger signal coming outside, then the hardware will interrupt, which will generate the interrupt, and then function a small piece of code inside the interrupt function will execute. The software interrupt, we will, in most cases, we will use software interrupt as that, for example, timer interrupt. When the timer is reached, the timer will trigger interrupt, and the software will generate some interrupt. Another is such as divide by zero. This is also a kind of interrupt. So in ARM processors, there are a lot of interrupt. However, in MCS-51, we will show some basic, only about 5 interrupts. We can see here. Before we do the experiment, we will first, I will recommend this software. This software have some code we can copy. There are some demonstration code, demo code, you see. So you can select the series, AT, for example, 89C551. This is also a series, so you can copy and paste this code to your KO platform. This is demo code. For example, this is IO demo. You can copy the code here. These codes are very basic, so it's very easy to understand. Then copy code. You can copy to your paste this code to KO platform. Okay. Now let's start do some experiment on how to use interrupt. First, I will create a new project. We name it interrupt. Then the file name, we give a file name, create a file name. Then select processor. Create a new file. Because we need a main file, so we create a new file. and select the directory, project directory, and name our file as interrupt main.c. Then add main.c to our project. Select our project, interrupt project, then main.c. So we have added the main.c to our project. This file is empty right now. And copy this code. We need to copy this code. Select the processor type. Demo code. We select this type. We will first illustrate a time interrupt. So we copy the code. Okay, this is the code. We can see here is please wait a moment. Here is the main function, and these sentences are for configure timer at a different mode. So in general, you can review some paper to some data sheet about this processor to see why the code is configured. For example, 1 to T mode register. However, I suggest you needn't spend too much time on research this detail. You just need to make the code running successfully. So based on this copied code, you can debug. If you want have some question, you can review, you can research this register on the datasheet. For example, here is timer 0, low register, high byte register. This is low byte register, high byte register. And this is time period. So we configured naming at T1MS. T1MS is defined on the micro-defined definition part. And here is timer 0 start. If you write TR0 equals 1, then the time 0 will start. ET0 equals 1 means we enable the time 0 interrupt generated. If you don't write this sentence, the timer 0 will never interrupt, but it will only start running, but not generate any interrupt. Just as the elevator is running, if you push the button, the elevator will never stop. So only if you have enable interrupt, then the interrupt can generate. There's a global interrupt enable, you must write EA equals 0. So it's open global interrupt. If you don't write this sentence, the interrupt will, all the interrupt will be closed. So you must write EA equals 0 if you want to use interrupt. And then as while 1, so the code will run in this place. However, when the timer interrupt generated, it will jump to interrupt section. So although the time is, although the code is running here, but after time reached its period, the interrupt generator, the code is jumped to interrupt piece, and then after interrupt routing have completed, it will jump back to this sentence. Let's see interrupt routing. Interrupt routing, we use keyword interrupt, then as number, interrupt number. For example, in MCS-51 or AT89C51 processor, the time 0 interrupt is designated to 1. So interrupt 0 always, or interrupt 1 always designated to time 0. So we write interrupt service tm/ISR. You can give you a write with your own function name, no problem. The most important is that you must write interrupt 0 or interrupt 1. Then here we reload interrupt period. This is low byte, this is high byte. GIMS is defined as 2 bytes. This is a word. A word equals 2 bytes. So this is a low byte, this is high byte, because we shift right 8 bit, so it's high byte. We extract its high byte to TH0, its low byte to TL0. TL and TH is used by timer 0. Timer 0. So it's consists of word. A word. Then we will use a counter. Each time, count will subtract itself. If equals to 0, we will reload, reset the counter to 1000. So I configure this period as 1 millisecond. So 1000 millisecond equals 1 second. So each second, the LED will flash. So test LED will turn on, turn off, turn on, turn off. This is test LED I defined in this place. Test LED. Then I compile, build the project. So I debug. Software debug. I can, during the software debug, you needn't use any hardware. So just debug inside the queue. We can see, I will add a breakpoint. What is a breakpoint? Breakpoint is a place that when the code reaches the breakpoint, it will stop. So let's add a breakpoint after a while. I will click here, add a breakpoint. this interrupt routine. I click at the breakpoint, then running. Click here, running. Each time it will enter into the breakpoint, you can see. If this not happen, you should solve the problem. Then let's see the port. I will open the port, parallel port, then let it running. You can see the last bit will turn on, off, turn on, off. So based on this software simulation, we will go to hardware simulation. It seems that the software is running okay. So we will create a hardware right now. I will generate an output, hexamer. Then open Pro Tools. We will create a hardware. First, I will create a new project. Then the path, we will select our directory, project directory. Interrupt. Rename the project name. We use portrait A0. Then select the default. No firmware project. Finish. Okay, a blank sheet is created. And we will place processor right now. Place the processor. Then LED place, find the LED which pin, P10. Okay. I will add a diode LED to P10. P10. We select optoelectronics category. Then select animated LED. You must select animated LED, otherwise the LED will not blink. Place LED. And then place a resistor. The resistor is used to limit the current passes through the LED. So in general, we will select a 200 ohm resistor or 300 ohm resistor. Because the average current passes through LED sometimes is from 5 milliampere to 20 milliampere. So based on the experience, I will select 200, select the resistor from 200 to 1000 kilo ohm, 1000 ohm. Then add a VCC, that is power. Add a VCC. Okay, we will upload our code. It seems the key haven't generated the hexadecimal code, so I need to reconfigure the path. Reconfigure the directory, review the directory to see if the hexadecimal have generated no hexadecimal. So need to change the path. We need to select the target, option for target, then output, select output, then select folder, then select our project directory. Okay. Then compile again, build the target. Okay, right now hexadecimal file is generated. Now let's upload the hexadecimal file. Then running. Simulator. It's blinking. The interrupt routine is running right now. This is software interrupt because it's generated by internal timer. Here is time period. So I write this micro define. The time period, you just copy this code. You needn't spend time on how to configure those time. It's really boring and tedious. So you just copy this code and make it running. It's okay. FOSC means current, the crystal frequency. The crystal frequency depends on the hardware design. For example, the general crystal frequency is this number. Sometimes is 12 megahertz. Sometimes is 11.0592 megahertz. But if you don't use this formula, you really need to search the book and find how to configure this TH0, TL0. If you're interested, you can do. But if you do project, I recommend copy other code, similar code, and revise it, and then you can use it in your project. If you want to adjust the blink speed, you can just adjust this count. So you needn't adjust the interrupt period, but inside the interrupt, you need to only revise this count. So for example, if I revised to 100, then LED will blink every 100 milliseconds. If I revised it to 1000, it will blink every second. If I revised it to 10,000, it will blink every 10 seconds. So I don't suggest you revise TRMS and this number. I don't recommend to revise this number. You just need to revise count. So it's more easy to revise the code. Sometimes, if you do some project, do not spend too much time on very low level hardware. Do not revise those low level code because it's really spend many time. Let's verify. I have a revised count equals 100, then compile again, then running on hardware. Let's verify if it's blink every 100 millisecond. Yes, it's running. It's more faster than before. Next, we will use another time 1. Just now we use time 0. This processor have two timer, time 0 and time 1. I will use two timer together and make the two timer have its own interrupt. So I will add another interrupt to the code. So copy this piece of code. You can see time 1 interrupt 3. Just now time 0 interrupt 1. But here time 1 interrupt 3. Why it's interrupt 3? Because it's arranged by the processor hardware. So if you design your own hardware, if you design your own processor, you can designate as, for example, interrupt 100, 1000, but the processor is designed by Intel company. So the interrupt 3 is already fixed, so you needn't, if you have question why I use interrupt 3, because the hardware have fixed the interrupt to number 3. So time 1 is related to interrupt 3. Okay, or we copy this snippet, code section. We copy this section to our our main file. Okay, I put it here. You can see time 0 interrupt 1, time 1 interrupt 3. Inside it's the same. So I only need to change count, then two interrupt will generate a different frequency. LED frequency. You also can change TIMS. You can use another variable to configure this new timer register. But you can also do not touch anything about it. We use same variable. So I only change count. But here there are some bug. I found I have make some mistakes here. Here I have some bug. What is the bug? Count is subtracted in this section, but also subtracted in this section. So it's conflict. You need to rename, create a new variable. For example, count 2. Then word here, word count. Then another sentence, word count 2. So count 2 and the count is different name. So these two variables will not correlated each other. Otherwise, there are some bugs. You see, there are some bugs inside. Okay, this section is for timer initialization. So we need to initialize timer 1. So I copy this code, and tr1 equals 1 means timer 1 start, and et1 equals 1 means enable timer 1 can generate the interrupt. If you don't write et1 equals 1, if you write it as et1 equals 0, then timer 1 will never generate any interrupt. So you must write et1 equals 1. I copy it to main function. Okay. One thing I want to mention here is interrupt routing. Here is your main routing. Interrupt routing is a separate code. You see it right here. It's a separate code, only triggered by interrupt itself. It's not arranged by our main logic. It's a separate code. So it's outside the main function. It's also not called by some code in the main function. For example, sub-function, we need to write, for example, if there's a function named ABC, I can call ABC here, like those code I write in previous section, previous lesson. But here we can find the interrupt is completely separated with our main function. Main function will never call the interrupt name. It's triggered by timer. If the timer is reached, there's a signal generated, and then the program will jump to this interrupt. And after the interrupt is executed, finished, it will exit and return to main. So this is interrupt. The detailed mechanism of interrupt you can see a lot on YouTube. I found on YouTube there are a lot of teachers teach interrupt and MCS-51, but I can guarantee 90% of them don't know how to develop. They have no experience on how to develop real hardware and software. So they just teaching. But sometimes you can understand some basic concepts from those YouTube. But for engineering development, it's nothing related. Build. Okay, I will change another LED after a while. First, let's check if the interrupt can enter. If you can't see, if you can't see, like, if you cannot see this arrow, then it means the interrupt have not entered. And after the interrupt is entered, you can see the program is stopped, and you can click this icon again. So here is a place you can check the interrupt if it can work properly. I change another LED, define another port designated to LED2. So 8-bit LED2 to another port. Okay. Compile. I will add another LED. First add a VCC. Then add animated LED. Add LED here. And also we need to add a resistor, which used to limit the current passes through LED. If you don't add a resistor, the LED will be damaged because the current is too large. Here the space is too small, so I will connect to P1.2. So I need to revise the code, revise the code to P1.2. P1.2. Okay, compile. And let's upload. Running. Okay, you can see it's Flash, but as I mentioned before, my code have some bugs, so you need to change the name of count to a different name. So although I have a bug, it still can running, but actually it have some problem. This is a very simple code. For those project, it's a bit complex. You know, sometimes you will spend a lot of time to find the bugs. I can change this configuration to and give it another name. So I can also, there's another option I can write here. So this is another option. You can also change its frequency. There's some problem, seems. I will expand its count number. Next, we will use another interrupt, external hardware interrupt. For MCS-51, this type, there are two kind of external interrupt. Interrupt 0 and interrupt 1. This is triggered by falling edge of the signal. So I will copy external interrupt. Its number is 0. ext int 0. You can name this name as you can revise this name completely. You can different with this name, but here you can't change. Interrupt 0 means external interrupt 1. The 0 interrupt. So I copy this code. Here we also need to open configure the external interrupter. So set the interrupter type 0. 1 equals falling, 0 equals low level. And here I enable external interrupter, EX0 equals 1. You can copy this code from this software. Okay, I open external interrupter and copy the code. Copy this section. Place below timer interrupter. You can place anywhere. I add an extra LED here. LED 3. And revise the code. I will blink the LED 3. So each time if there are falling edge detected, LED 3 will blink. Let's add a LED here. First, I will falling edge. So because here it is set as a falling edge equals 1, means falling edge, the signal is a falling edge. So I will design a hardware, make it generate a falling edge. So I must connect a pull-up resistor and then connect a button. You can see how I design the hardware right now. I will connect a resistor. First connect a button. Place okay, I press connect a button. You must connect the button to this pin because it write interrupt 0. You can see interrupt 0. Here is interrupt 1. So you must connect to interrupt 0 because the program is designed to interrupt 0. Then I will add a pull-up resistor. The button needs to connect to the ground. And on the left of the button, you must connect a pull-up resistor. If you failed to connect a pull-up resistor, then this pin is floating. So you must connect a pull-up resistor. From the experience, we can connect a 10,000 ohm resistor, or other values, for example, 20,000 ohm resistor. connect to VCC. So here is a pull-up resistor. Be careful. Be careful here. If you place your device on industrial heavy interference place, you must reduce the value of this resistor. If you place your device on laboratory, on some other place, for example in home, there are less interference, so this resistor can be a bit large. Because the smaller the resistors, the strong the pull up, and the interference will seems not able to change its voltage level. I will add a LED to indicate if the interrupter have generated successfully. I will add a resistor. Build the project and upload it. Okay, it's blinking. You can see I push the button. The LED is flash. Each time I push the button, LED will blink once. Okay, so in this video, I have demonstrated how to program the timer interrupter and external hardware trigger interrupter. Next video, I will teach you how to program UART, how to program serial port communication. Before I illustrate the serial port, I will revise the external trigger interrupter, because just now I use a button to trigger the interrupter. However, in the practical hardware, the trigger is generated by signal. For example, the signal is from other device. So in this place, I will add a signal, make it generate the falling edge, and then observe if our code can running smoothly. First, I will add a device, G-pulse. G-pulse generates digital pulse. Okay, I add a G-pulse. Then I configure the pulse period as 0.5 second. Then click negative. This is falling edge. Generate falling edge. Because we want to observe several interrupts, so I select pattern mode. Pattern mode. And let it running several times. For example, I let it running 20 times. Okay. Then save the file and start debug. We can see it's blinking. D3 is blinking. D3 is blinking because it's generated by this pattern. After finished, D3 will not blinking anymore. You can see D3 is not blinking anymore. Because here, no signal generated anymore. Next, I will add another device, virtual terminal. I will program how to make the processor communicate to outside the device by serial port. So in this place, you need to connect virtual terminal RxD to TxD because TxD is send out signal and RxD is receive signal. So the virtual terminal have send out strings, send out characters, send out data through this wire and to RxD. RxD is received by processor. And the processor will send out data through TxD. And here TxD and to receive pin RxD. So this two pin is you should connect RxD to TxD and TxD to RxD. Do not connect RxD to RxD, otherwise it will not work. Okay, we configure baud rate. Baud rate is communication speed. So you can see you must match the terminal baud rate with the processor baud rate. If the terminal baud rate is different with the processor baud rate, then you cannot observe anything on the terminal. So you must make sure that two baud rate is completely same. And then as data bits, the general used data bits is 8 data bit. So parity, we can select none, but in industrial occasion, you can select parity or odd. Parity as odd or even. You can select different checksum, even or odd checksum. But usually, during experiment, we select none. You can select none even in industrial, but you need to add CRC checksum by yourself. You can use CRC even if you select here, even if you select odd or even parity, there's still some possibility it will generate error, but not detected by other side. So if it is used in high reliable place, I suggest you to design CRC checksum. But you need to implement CRC checksum by yourself. You can copy those code from network and paste it to your own function and then debug. It's not very difficult. Then stop it. Stop it. The general used stop bit is 1 bit, sometimes 2 bit, or 1.5 bit. And then we switch off all the X on or X off, and switch off RX TX port. We use normal. We also needn't any flow control. Serial port only we use 2 wire. We needn't any RTS, CTS. RTS, CTS is shake hands. Hardware shake hands. It's used to control the flow, but in general, we never use it. Okay, I will copy code UART communication. UART communication. Find a code UART communication. UART demo. Click. Hey, sorry. Hey. It seems to have some problem. Wait a moment. I click somewhere. Okay, right now I will paste the code from the demo software. Copy this code, UART communication code. These are all the common used code. I copied it to my project. And then revise the baud rate. Then we can see in the first section, they define the FOSC. This is the main frequency of the crystal, and the baud rate. This is micro defined. It's defined here. Why you use micro define? You can use these numbers directly in your code, but if you use micro definition, it's easy to change this code. You needn't change each place when this value appear. You just use BAUD instead of 9600. So you only need to change it in one place. Needn't change it every place when each time baud is appear. This is the same. Then at the time you compile the project, compile the file, the BAUD will replaced by this value. This is work is done by Q compiler. So it's micro defined as only a preprocessor. A compile processed by compile preprocessor. And then the non-parity equals 0 to, you just copy this code. We can also define parity bit, non-parity. If you don't like it, you can write 0 instead of all this micro definition. You just write 0 in your code. You needn't write so much. But if you customized to this writing style, it's more easy to revise the code. Send the data and send the string. Send the string will call the function send the data, so we will see after a while. And in the main function here, they use micro. Also, this if is different with other. In front of if there's a special character. This is also used by preprocessor of the compiler. So if you define the parity bit equals non-bit parity here, if you define here, only scorn equals equals this number will appear in your program. During the time compiler is process your file, only this number will designated to this scorn. Other is omitted. This is omitted. This is omitted. So we use if and else if, if and if. It's different with those if else else in the program. Then the send data. How to send the data? You just copy it. If you curious about why I use data, ACC equals data, because ACC as a register, data is configured to this register. A new value is loaded to this register. After this register is received the data, then the hardware will automatically send out the signal. So here, when you write ACC equals data, hardware will send it immediately. Then the next is odd parity or even parity checksum. So why TB8 equals 1 or 0, this is used by hardware. This is a flag used by hardware, only a bit inside a register. So if you want to know why I use TB8, then you can see data sheet. You should spend some time to see the data sheet. But nowadays, the microprocessor is rather complex, so it's almost impossible for us to see all the details about the data sheet. After you have understand all the detail about the processor, you need to see several thousands of data sheet, several thousands of page of data sheet. It's almost impossible. Your project already failed if you spend so many time on data sheet. So I suggest you copy those code and do some revise and make it to your own, merge it into your own project. If some place during debug have difficult, you really need to see some section of the data sheet. You must see it. Otherwise, the project is stuck. It will fail. So you must solve those problems by yourself. Okay, send a string. I will call this function, send function. this send string is also will generate interrupt. This interrupt will process not only send out interrupt, but also receive interrupt. So here is send out interrupt. Here is receive interrupt. Here enable UART interrupt ES equals 1 means enable serial port interrupt. Then at the time you use serial interrupt specifically for this processor MCS-51 series. For this processor you need to use time 1, so time 1 cannot be used by other function. It's occupied by serial port, so it is auxiliary to serial port. But in ARM processor, things are different. Only in MCS-51 have this problem. Okay, I copy this code to while function, so it will repeat send this string. Then generate our hexamal. Generate hexamal. Okay, upload. I need to change this clock frequency. If you do not change this frequency, it will consist. It must consist the frequency designed in your software. Otherwise, the baud rate will different. Here is consist with the hardware. You can see two place consist. Okay, let's run it. Okay, here the virtual terminal have output the character repeatedly. Next, I want to define a receive function. So here I define a receive buffer, but for the purpose of simple, we will use it later. Right now, we will not use the receive buffer. I only use a very simple register to demonstrate the receive. You can revise the code here. If you send a hexamal AA, then LED will shut off. If you send a hexamal BB, the LED will turn on. I can also revise the BB. For the ease of use, you can also revise the code as a string, hexamal code, ASCII code. It's more easy. can define a new port for this LED. Add a resistor. Okay, I have a revised code, and the next is for you to debug by yourself. You can verify the result. If the result is not satisfied, you can change your code and debug again. And next, I will illustrate. I will do another illustration. Lab Center. The Lab Center Pro Tools also have some example. So let me open it. From next time, I will shift the processor from MCS-51 to ARM processor, because MCS-51 is already is outdated, but still in many Chinese university they only teach MCS-51. There are very little teacher have grasped the development technology of ARM. But in the company, all the products are designed based on ARM. So sorry, it seems it's starting. So MCS-51, if you learn MCS-51, it's only for the purpose of grasp some basic techniques of single chip microcomputer developing. But for practical, I think you can still use it in Africa or other place. But If you want your product to sell to American, to German, to some advanced country, you must learn ARM processor. There's some difference between the ARM processor and the MCS-51 because MCS-51 is emerged about 1990s, but nowadays very few people are still use MCS-51. Some aged engineer, more than 50 years, 45 years old, they will not want to learn new technology. They use some older processor. Please wait a moment. My computer have. I use a virtual VMware workstation. It have updated. Okay. But for ARM processor, the technology is almost the same. Interrupt, falling edge, rising edge, software interrupt, hardware interrupt, GPIO, UART communication. All these are same. Only difference is we use different tools, different architecture. But the basic developing technique is the same. So this is why I use MCS-51 as an example. I open a lab center, produce example. You can find the example in the directory. You can see my our web station. Here I passed some example here, and the example for Produce can find, if you install the Produce, you can find in this directory. So you can browse this caoxing.com. We can see in this example another kind of 8051 processor. The core is the same, but there are some peripheral a bit difference. It have designed two virtual terminal, terminal 1, terminal 0. We can see the source code. In our project, we always include reg51.h, but here, because this processor have some extra hardware, so it have added some function, S-bit. This is provided by the factory. You needn't design by yourself, provided by the factory. Then you can copy this code. You only need to see this system clock init is used to initialize the clock, just as our code. For example, here you can see the function sysclock. Why it's different? Its name is different because the hardware register is a bit revised by other. This you can see this chip mode is different. C8051 F380, but the core is completely same. Only some register, some preference, internal preference is different. So after you grasp the basic technology, other is very easy to learn. After this is finished, then we can see main port init. This is initialize some GPIO port. Then UART 0, UART 1 init. You can see how to init UART 0. It's the same as our code I illustrated before. Scorn, then the baud rate. This is baud rate. Although the code style is different, but the concept is all the same. Also connect with time 1. T mode will configured. After UART 0 is initialized, you need to initialize UART 1 and then start to print UART 1, UART 0, UART 1, start to print. Then here is the receive function. If you received getChar, what is getChar? In DOS operation system, maybe several years before, we always programming getChar, but here getChar you need to write by yourself. What is getChar? Here is a function getChar. I received from UART. If you use UART 0, then I received from this register ASBOF. If this UART indicator flag is, if UART have received something, it will set to set to 1, and then it will execute this code and return the character. So this is UART 1 0, UART 1 receive function. It called getChar. Then the getChar is the value is set to input char. So here we print out input char. How to use printf? You can also see printf. Printf is also written by ourselves. Printf. It seems the printf is written in other place, but if your processor can't find the printf library, you need to write printf by yourself. Okay, we compile and build a project. You can copy it to Q, and then here we run simulate, debug, run simulation. Then terminal is appear. If you can't find, sometimes if you closed, you can't find how to open terminal, you can click debug. You can see here virtual terminal, click. You can see debug, virtual terminal, click. Okay, here is output. If I input something, it will receive it and then write back. But for UART 1, the program haven't received it, and the program haven't echo it. So it haven't this function. I click keyboard, nothing happen. But here, I click keyboard, it will output some character because the code have executed. Okay, this is some simple project experiment I illustrate about how to program UART, how to program interrupt. 郭老师啊，差不多了。郭老师，
结束吧。
那